In this lesson, we're going to look at problem solving in standard form of a linear equation. Please write down your essential question and restart the video when you are ready. Okay, so writing using standard form in problem solving is actually a ton easier, I think, than doing slope-intercept form or doing point-slope form. The biggest thing that needs to happen when we are looking at word problems and we know we're going to end up writing them in standard form is we're not going to be given the slope and a point. We're not going to be, or 2 points. We're not going to be given information like that. One thing that we need to do is we need to make sure that we look for totals. We look for total amounts that are given. Because number one, that's going to help us know what our equation needs to be equal to. Okay? So let's look at the first problem. It says a banquet room, that should say has large and small tables. A small table seats 4 people and a large table seats 6 people. The guests at a banquet can fill 9 small tables and 4 large tables. Okay, now, we don't necessarily have a straight up total right here, okay? We would know, we need to decide what do we want our variables to represent. It doesn't tell us here. So I'm going to say that X represents the number of small tables and that Y represents the number of large tables. Okay? Now, it does tell us that the guests at a banquet can fill 9 small tables. Well, if 9 tables with 4 people each, that would be a total of 36, right? 9 times 4. And then they can also fill 4 large tables, and there's 6 people at it. So 4 times 6 is 24. So what that tells us is we have a total of 60 people. A total of 60 people. So they gave us information so that we could determine the total for ourselves. Now you would then be saying, well, Miss Adams, why do we need to write an equation? Because we already know how many tables. Well, you know that if you're in a banquet hall or in a room with tables, then you could have different combinations. So to write an equation in standard form that models the possible combinations that we could have, we know that our total is 60. Okay, and then we kind of already did it. Well, if X is the number of small tables and 4 people can be at each table, 4 times X would represent all the people at the small table, plus 6 times Y would represent all the people at the large tables. So very simple, right? I didn't have a point, but I had numbers that we knew we were going to need to multiply by our variables. So that's kind of what we're looking for. We're looking for 2 numbers to multiply with our variables. So we need a total and we need numbers to multiply with our variables. Okay, now the next part says give 3 possible solutions. Now, a couple of different ways we could do this. Number one, we could graph this, we could read our line, and we could determine possible combinations. We should also remember that it's very easy to find our intercepts from standard form. So for example, my x-intercept would just be 60 divided by 4, which is 15. So if x is 15, that means we could have 15 small tables and 0 large tables. That's one possible combination. And in COVID times, we might want small tables, so there's less people at it. Okay, for our y-intercept is 10, so that means we could have 0 small tables and 10 large tables. So that would be another possibility. And then again, we could then graph and read our line. But let me give you another possibility. What if I say we will use 8 large tables. We will use 8 large tables. How many smalls do we need? Okay, so maybe I tell you how many we have for one, and I want to determine how many of the other we need. And so this is just another example where we take our equation, we take our given number, and we plug it in. Now, large tables was my y, so I'm going to plug in 8 for y, and I am going to solve this equation. So this would be 4x plus 48 equals 60. And so then when I subtract 48, I'm sorry, I'm kind of out of room here, this would be 4x equals 12, and so x equals 3. So that would mean that I needed 3 small tables. If I have 8, I need 3 small tables. Okay, let's look at the next example. Read it to yourself, please. Okay, so let's see. So first of all, remember, we want to look for a total. So I see a total right here. We have $1,600 to spend. It says each large raft costs $100. Each small raft costs $40. So there's our numbers to multiply. And so I'm going to use L for large. And I know S is bad, but I'm going to use S for small. Okay, and so this is super easy. We would say 100 times L plus 40 times S equals 1,600. Super easy, right? That's our equation. That's our equation that represents this situation. Now it says find 4 possible combinations. So again, I'm just going to ask you, look for your intercepts. Okay, we can just almost cover it up. We're plugging in 0 for S. So for large rafts, that would be 16. So we could have 16 large rafts, and then that would mean 0 small. Okay, or to find my other intercept, 1,600 divided by 4 is, 1,600 divided by 40 is 40, right? So I could have, just keep it consistent here, 40 small and 0 large. Okay? Again, we could graph this. We could look on our graphing calculator to get some more points. Let's say that I tell you we will use 10 small rafts. How many large do we need? Okay, so that's another example. So I'm going to go back to my equation. I'm going to take 10 and I'm going to plug 10 in for my S. Remember, it's okay if you want to use a different variable. I was just trying to use variables that relate to what we're talking about. And so now I'm going to solve for L. So this would be 400. And then subtract 400 gives me 1,200. And so that would mean that if I have 10 small ones, that I need 12 large rafts. Okay? And that's it. That's all there is to problem solving with standard form.